Hello dear students, welcome back to another lesson. In this lesson we are going to start section 3.4, which is about rates of change. Rates of change is a very easy section, and there are always questions about rate of change in the auxiliary exam. So pay attention in the beginning so you can understand it bit by bit until you can control the section 3.4 altogether. Okay, firstly, rates of change are not only one thing, there are different things. This begins with velocity, acceleration, and position function. We have s of t is the position function. Wherever you see s of t, that is the location, the position or distance. Then if we take one derivative of s of t, it will be s prime. Then s prime is velocity. Or to be more specific, v of t is instantaneous velocity. That means a specific velocity at a specific time. And then we have speed. Speed is the absolute value of velocity because speed is always positive. And if we take another derivative of s of t, it will be s double prime. And s double prime is representing acceleration. Let's have two more rules and then solve an example. Average velocity is distance over time. Velocity is speed and speed is distance over time. Here the distance is st2 minus st1 over t2 minus t1. This is average velocity. Average acceleration. Acceleration is speed over time. Acceleration is vt2 minus vt1 over t2 minus t1. Now let's solve this example. Take the example to the notebook and solve it. There you go. A point moves on the x-axis. The function s of t, this is important, s of t is t squared minus 5t plus 4. Is the position function. Then t is measured in seconds. Find average velocity. Average velocity has a rule. Average velocity, velocity average, is equal to st2 minus st1 over t2 minus t1. Let's find each of them. If you continue reading the question, find the average velocity of the point during the first 2 seconds. The first 2 seconds means t1 is equal to 0, the beginning, the timer was 0, and after 2 seconds, so t2 became 2. Whenever you see the first 2 seconds, t1 is 0, t2 is 2. The first 3 seconds, t1 is 0, t2 is 3. There is a auxiliary question that says the first 4 seconds, so t1 is 0, t2 is 4. In this case, for this example, first 2 seconds, t1 is 0, t2 is 2. st2 means I have to find s of 2. Put 2 in place of t here. S of 2 is equal to 2 squared minus 5 times 2 plus 4. And s of 0 is equal to 0 squared minus 5 times 0 plus 4. 2 squared is 4 minus 5 times 2 is 10 plus 4. So 4 minus 10 is negative 6 plus 4, that is negative 2. And here this will be 0, 0, that is 4. Now st2 minus st1, st2 is negative 2 minus st1 is 4 over t2 minus t1, 2 minus 0. The answer is negative 6 over 2 which is negative 3. Then negative 3 is the average velocity. Now, why this is negative, that's okay. If it's negative, the position is negative, means the point is moving to left. Why left? Because the motion is horizontal, so we only have left, right. That is the average velocity. Then it says find instantaneous velocity at t equal to 2. Instantaneous velocity is the normal v of t, which we get it from derivative of the given function s of t. So s prime of t is the derivative, is equal to 2t minus 5. If we input 2 times 2 is 4. 4 minus 5 is negative 1. So s prime of 2 is equal to 2 times 2 minus 5, which is equal to negative 1. What does that mean? That means v2 is equal to negative 1. v2 is equal to negative 1 because v2 is the same as s prime. Then the answer is complete. Let's go back to the book. The question did not ask for acceleration, but if we want to find acceleration, we just do one derivative of v of t, which is derivative of s. Derivative of that is 2. That means acceleration of this point is 2, and the acceleration is constant. Acceleration is constant means the point does not speed up or slow down. What is the average velocity of the point during the period from t1 equal to 3? See, t1 and t2 are clearly given, or the question says in the first 2 seconds or the first 3 seconds or any other number. Now, t1 is 3, t2 is 7. If I want to find instantaneous velocity, I just have to do derivative and input 5. If I want to find average velocity, I have to use this rule. Now, st2 means put 7 in place of t here. So if we put 7 in place of t, this will be 7 squared minus 5 times 7 plus 4. 7 squared is 49 minus 35 plus 4. 49 minus 35 plus 4, this is 14 plus 4, that is 18. And this is s of 7. If I want to find s of 3, I just replace every t with 3. 3 squared minus 5 times 3 plus 4. 3 squared is 9 minus 15. 9 minus 15 is negative 6. Plus 4, that is negative 2. Now, I write here in place of st2 18 and st1 is negative 2. Then it looks like this. Over t2 minus t1, t2 is 7, t1 is 3. 7 minus 3 is 4. Then 20 divided by 4 is 5. So the average velocity is 5. Now, if I want to find the instantaneous velocity, as I said, we just have to find derivative and then input 5. The derivative s prime t is equal to 2t minus 5. That means v of t is equal to 2t minus 5. We want the velocity at t equal to 5, so that is 2 times 5 minus 5, which is equal to 10 minus 5, that's 5. So instantaneous velocity is 5. This is for vertical motion. For vertical motion, if the function s of t is not given in the question, which we have it in this way in a few exercises, the function s of t, the position function, is not given. we need to know it ourselves because this is vertical motion. We have two functions that are quite identical. The only difference between them is the unit. If the question is in terms of meters, we will use negative 4.9 t squared plus v naught t plus s naught. What is v naught? V naught is the initial velocity and s naught is the initial position. Well, if the question is in terms of foot or feet, foot is the singular, then we use negative 16 t squared plus v naught t plus s naught. This part is the same for both equations, v naught t, s naught. This coefficient of t squared changes according to the unit. Now we have an example. In a fireworks festival, a rocket is launched upwards from the height of 4 feet. The question is in terms of feet, so I have to use the negative 16 t squared. Negative 16 t squared plus v naught t plus s naught. And this 4 feet is directly s naught. It's the initial position of the ground at an initial velocity that is clearly given. Initial velocity is v naught, 160. So this 160 goes here next to v naught. Part A. Write the position function for the motion of the rocket. Then s of t is position function equal to negative 16 t squared plus 160 t plus 4. This is the position function. Then part B, what is the highest point the rocket can reach? Well, this position function is a negative quadratic. Negative quadratic has a graph of an upside down parabola. Then this is the highest possible point where the rocket can reach, which is the axis. There are two ways to find it. The way that most of the students use is to use chapter 4. In chapter 4, how do we find maximum and minimum? We just find derivative equals 0. Or here we can say a rocket can reach the highest point where the speed becomes 0, because when we launch a rocket upwards, the rocket speed is very high, and as the rocket rises up, the speed reduces, and eventually the speed becomes 0 where the rocket reaches the highest possible point. And after that point, it starts going down again. Okay, we can find this by finding the derivative and then equals 0. We want to find when the speed becomes 0. Derivative of this is negative 32 t plus 160. And if we set this to be equal to 0, it's very easy to solve. Divide both sides by 32. 160 divide 32 is equal to 5. That means t equal to 5. What's the meaning of this 5? This 5 is when. But the question says, what is the highest point? So we need to find the height. So we have to put this 5 back into s of t and calculate. That is negative 16 bracket 5 squared plus 160 bracket times 5 plus 4. The answer is 404. This means the highest possible point where the rocket can reach is 404 feet above ground, and this happens 5 seconds after the rocket launch. Part C, what is the velocity of the rocket when it reaches 260 feet upwards and downwards? 260 feet is somewhere here. Then how can we find the time where the rocket reached 260 feet? Then we put this time into the derivative of s of t, which is velocity. Then we can find the speed or the velocity. Let's remove these. And start. Let's do this one here. The s of t was like this, s of t equal to negative 16t squared plus initial speed or initial velocity 160t plus 4. I want this position to be 260. So negative 16t squared plus 160t plus 4 equal to 260. This is a quadratic equation. If we solve it, we get two answers automatically. And one of them is the upwards 260 and the other one is the downwards 260. Okay, let's send 260 to the other side. So negative 16t squared plus 160t. That's positive, this will be negative, so minus 260 minus 4 is 256 equal to 0. These three numbers are all divisible by 16. Let's divide by 16 to make it look easier. Or we can divide by negative 16 to get rid of this negative as well. Then t squared minus 160 divided 16 is 10. Minus minus will be plus 256 divided 16 is equal to 16, equal to 0. Now we can solve this making two brackets. Think of two numbers, when you multiply you get 16, when you add you get negative 10. That is easily negative 2, negative 8. Multiply positive 16, add negative 10. So there's t and there's t equal to 0. So from this bracket t is equal to 2, and from this pair of brackets t is equal to 8. If we think logically, the 2 is the upwards. After 2 seconds, the rocket reaches the height of 260 feet. And the other one, this takes 8 seconds for the rocket to reach the other 260, which is downwards. Now we have two t's. If we want to find velocity, we just take one derivative of s of t. So s prime t is equal to negative 32t plus 160. Now V2, put 2 here, negative 32 times 2 plus 160, that is V2. Negative 32 times 2 plus 160 is 96. So the velocity is 96 upwards, and downwards v of 8 is equal to negative 32 times 8 plus 160. Negative 32 times 8 plus 160 is negative 96. Why this is negative? Because this is vertical motion, the question. Here at t equal to 8, the rocket is going downwards, then the velocity is negative. While when t is equal to 2, the rocket is going upwards, so velocity is positive. Let's go back to the book. When will the rocket reach the ground? The rocket reaches the ground when the position s of t is equal to 0. Just solve that, s of t equal to 0. Solve this, you'll find the time where the rocket reaches the ground. I'll leave that for you. These are the solutions. You can take screenshots. When the rocket reaches the ground, this is the position function equal to 0. This cannot be factorized to two brackets. We can just use quadratic formula. Negative b plus minus b squared minus 4ac over 2a is quadratic formula. You studied in grade 10. You studied in grade 9. You studied in grade 11, chapter 5. Then, if you don't know this as a grade 12 student, now you have a chance to memorize the rule and use it practically. We will have two answers. One of them is negative, which we ignored. Time cannot be negative. And the other one is 10. That means the rocket reached the ground by 10 seconds. There is another way. The rocket reaches the highest point by 5 seconds. Highest point takes 5 seconds for the rocket to reach. That means it needs another 5 seconds to go back on the ground. 5 plus 5 is 10. So the rocket takes 10 seconds to reach the ground again. You can also use this idea. This is your homework. Apply everything of the previous example for this situation. What is the S of t while the unit is meter? And then do A, B, C, D until E for this situation. Now exercises. Question 1. Area. A rectangle has a length of 2t plus 1. There is a rectangle. Length is 2t plus 1. Width is radical t. Okay. Find the rate of change in the area. Rate of change just means derivative. If we read the question again, replacing rate of change with derivative, the question simply says, find derivative in the area. Okay, what is area? Area of rectangle is length times width. Then let's take this to the notebook and solve it. The key for such questions, rate of change questions, is to replace the part that says rate of change, replaced with the word derivative. Derivative sounds much easier. This means find derivative of area. Okay. In the beginning, what's area? Isn't area length times width? That is 2t plus 1, which is length, multiplied by width, which is radical t. This is area. If I want to find rate of change of area, I just have to do derivative for both sides. Derivative of area, let's call a prime, that's derivative, or rate of change of area. And here, we can multiply this by inside, then do the derivative, which is easier. So let's rewrite 2t times square root t. This t is power 1. This t is power 1 over 2. In multiplication, we add the powers, so we will have 2t power 1 plus 1 over 2 is 3 over 2. Plus 1 times anything, it will be the same. T square root t is t 1 over 2. Now let's find derivative. This is not the only way. We can also use the product rule. First times derivative second plus second times derivative first. Both ways work. Here, since I did this simplifying, let's do the derivative. Power goes down, power minus 1. So the 2 stays the same. 2 times 3 over 2 t power. 3 over 2 minus 1 is 1 over 2. Plus 1 over 2 t negative 1 over 2. Simplifying, 2 cancels 2. here I have 3 square root t plus 1 over, this 2 is already down, stays down, square root t. This is the answer. If in the multiple choices they simplified it more, we can find common denominator. The common denominator is this denominator, so we write it up and down. We write it 2 radical t down and 2 radical t up. Then multiply, simplify, we can get the final answer as one fraction. 2 times 3, 6. Radical t times radical t is just t plus 1 over 2 radical t. We can also simplify this further. Having radical or having square root in the denominator is not simplest. And we just multiply up and down by square root t. Then the square root t times square root t will be just t in the denominator, and the numerator contains square root. This simplifying or this simplification is based on the multiple choices. At the end, we want our answer to look like the multiple choices. Then we can choose the right answer. Okay, question 2, volume. The radius of the base of a cylinder of revolution is radical t plus 2. And its height is 1 over 2 radical t. Find the rate of change of volume. As I said, find rate of change of volume means find derivative of volume. So we need to begin with the rule of volume. What is the rule of volume of cylinder? Rule of volume of cylinder is area of the base times height. The base is a circle. Area of circle is pi r squared times height. The height is given 1 over 2 radical t. Then volume of cylinder is pi r squared times h. For our case, radius is square root t plus 2. Then pi square root t plus 2 power 2. That looks like this, pi square root t plus 2 power 2. That's area of the base times height, which is 1 over 2 square root t. Here on the side, square root and power 2 cancel out, so we will have pi t plus 2 times 1 over 2 radical t. This 2 is already down, stays down. Pi is a constant. Multiply these two. When we multiply, we'll get that. This is the volume. Find rate of change of volume is just find the derivative. Using quotient rule, using product rule, sorry, that's product, not division, to use quotient rule. Using product rule, we're going to say first, which is radical t, times derivative of inside, t plus 2. The derivative is just 1. Plus t plus 2 is the same, times derivative of square root. If we have square root x, the derivative is 1 over 2 square root x. If we have square root t, it will be 1 over 2 square root t. This is the derivative. After that, it's only simplifying. Okay. Another type of rate of change is chain rule. Chain rule is very important rule. dy over dt is equal to dy dx multiplied by dx dt. This rule must be memorized. It's very important. Now if you look at this rule, we have 3 terms, dy dt, dy dx, dx dt. In these 3 terms, always one of them is given clearly. One of them is given clearly, let's say this. One of them, evidence are given to find, and one of them is missing completely. So this one is given. This one we can find it, then multiply them, the result will be the missing one. In these 3, always one of them is clearly given. The other one we have some evidence to find it. And the third one is completely missing, so we find 2, multiply or divide them to find the other. Questions 4 and 5. Let's do them. Okay. What is chain rule? Always when you go to the exam, your first job is to write chain rule because it's very easy to confuse. Chain rule is dy dt. dy dt has a name, it's called rate of change of y, equal to dy dx. dy dx is normal derivative, the derivatives we know, multiplied by dx dt. dx dt is rate of change of x. We can think like this, dx cancels dx, what's remaining is dy dt, and on this side we have dy dt. This rule is correct. That's a way to check if the order you wrote is right. Now, y equal to radical x. This y equal to radical x is evidence for us to find dy dx. If y is equal to radical x, what is dy dx? dy dx means derivative, means y prime. Square root of x, the derivative will be 1 over 2 square root x. Okay. Now, we need to turn dy dx to a number. Look back to the question. There's definitely evidence given. X equal to 4. Put 4 in place of x. That's going to be 1 over 2 radical 4. Radical 4 is 2. 2 times 2 is 4, so we get 1 over 4. This dy dx became 1 over 4. And dx dt is already given. It's equal to 3. So let's make the answer clear. dy dx, I know it's 3, multiply by dx dt, dy dx, I found it, it's 1 over 4. dx dt is given, it's 3. The result is dy dt. Multiply these, dy dt is equal to 3 over 4. Finished. We found the value of dy dt. Let's do question 5. We'll use the same chain rule, always. You tell me where to start. Let's make the answer clear. What's clearly given is dx dt equal to 8. dy dx, dy dt is missing. That means we have to find dy dx. dy dt is missing, dy dx, we should find it. When we look at here, it's implicit differentiation. But don't worry, we know how to do implicit. Y prime is equal to negative f prime x over f prime y. That means derivative according to x divided by derivative according to y. Derivative according to x, for this case, it's just 2x. Derivative according to y is 2y. Don't forget the negative. There is this negative, it's ruled to go next to derivative according to x. Now the answer is negative x over y. Look back to the question. X and y are both given. Replace. Negative 3 over 4. What is this? That is dy dx. Negative 3 over 4. Now replacing. dy dt is missing. Equal to dy dx, we found it, it's negative 3 over 4. dx dt is given, it's 8. Multiply, that is 4 cancels 8 to be 2, that is negative 6. So dy dt is equal to negative 6. That was the first part of question 5. Now let's do the second part. In the second part, this time dy dt is given, dx dt is missing. We know how to do it. So don't panic, don't rush, you can do it. Make it clear what's given. dy dt is given, that's -2. Okay. Function is given, so we can find dx dt, dy dx. We can find dy dx. dy dx is y prime. That's equal to negative derivative according to x over derivative according to y. We just did, that's negative x over y. Replacing the values of x and y, that is -4 over 3. Okay, now dy dt, we know dy dt is -2 equal to dy dx, which is y prime, we found it, it's -4 over 3. Multiplied by dx dt is completely missing. How can we make dx dt the subject? If we divide -2 by this fraction, or we can say multiply both sides by 3, -6 equal to -4 dx dt. Divide both sides by -4, so 6 over 4 is equal to dx dt. 6 over 4 simplifies to 3 over 2. So dx dt is equal to 3 over 2. Exact same idea. A particle moves on the graph of the given function y. Find dy dt at the given value of x, knowing that dx dt is 2. For questions 6 and 7, for both of them, dx dt is equal to 2 whenever we need it. A function is given, so I use the function to find dy dx. And then replace the value of x. We have 3 x's, that means we find dy dx 3 times 3 different values, and using dx dt 2 all the time to find dy dt 3 different times. Now let's do question 7. Question 7, y equal to sine x. What is dy dx? dy dt is missing. We can find dy dx. dy dx is normal derivative. Derivative of sine is cosine x. That's dy dx. And this is dx dt, which is equal to 2. If we put pi over 6 in place of x, pi over 6 is, never use pi in the calculator unless the calculator is on radian mode. Now, most of the time calculators are on degree mode, or when you practice math only on degree mode. And instead of pi, I use 180, divide by 6, that is 30. So what is cosine 30? Using calculator, you will get this answer in your calculator, which is okay, we can use it. This makes your final answer decimal, and then change the multiple choices to decimal, see which one is matching your answer. I'm taking 0.866 as cosine 30, so 0.866. That is dy dx. If I multiply dy dx by dx dt, which is given, which is 2, the result will be dy dt, which is missing. Then 0.866 multiplied by 2, 0.866 multiplied by 2 is equal to 1.732. Then if we look at the multiple choices, 1.73, this is for the pi over 6. In the multiple choices, there is radical 3. Okay. What is radical 3? Use calculator. The answer is supposed to be 1.73. Okay, radical 3 is 1.73, so I can choose this. Then don't worry, if in the calculator you get decimal, this decimal is okay. Make the final answer or the multiple choices decimal, see which one is the closest, or see which one is matching. Question 8 is about distance. I'm going to stop here for this lesson. Distance needs some explanation of distance rule and then applying it. So this is the end of this lesson. Thank you so much for watching. Comment below your questions. Don't hesitate to ask your questions. Send me your questions on any platform. I don't have problem. Inshallah, I'll answer you. And stay tuned.